Hi everyone, my name is Juan Pablo. Welcome back to this second part of the series of MPLS LDP versus SR-MPLS. Previously, we did a video about explaining the difference between MPLS LDP compared to segment routing, why segment routing was and is so attractive compared to LDP, what are some of the drawbacks that MPLS LDP has with different type of components, how it works, traffic engineering, and other points that we saw in the previous video. This time we will focus on how to configure segment routing, how to configure the prefix it. We will talk about how to verify that the control plane are correctly implemented, what are the commands that we need for enable segment routing in the control plane and in the forwarding plane as well, how we can verify that the labels are distributed, the prefix it, the adjacency it, and also we will test it out that the traffic or the end-to-end LSP between one device and another is correctly working. We don't need to have service over the network to verify that the underlay is working in segment routing. There is an option that we can do, the same with MPLS, right, with LDP, to verify that the end-to-end or traffic between one P to another P is labeled. Okay, so let's start with the lab. We have this lab over here. We have this lab over here, as you can see. So in this network, we have the P1, P2, right? They are basically having users over this interface. This is in a VRF blue, okay? This as well is in a VRF blue. Then in the core, we have MPLS LDP. I configure MPLS LDP because we will show you how to move from LDP to segment routing, right? What are the commands and exactly what is the command that you need for the forwarding plane switching of the labels, okay? Then we have P2, P1, they are connected to each other. They run ISIS in the area 1. On the top, we have a route reflector. This route reflector has a VPN before session with the Ps, right? Over that VPN before session, the P1 and P2 redistribute the routes that they receive from the CE. So in C1, we have a loopback 0 that has the IP 100, 100, 100, 100. And in C2, we have the loopback 0 that has the IP 200, 200, 200, 200. Okay? So our test basically will be to ping between this loopback to this loopback whenever we implement segment routing in the core. Okay? That will be our final test. But C1 runs, just to explain a bit more the scenario, BGP with the Ps, they run BGP, they exchange the loopback 100, the P1 redistribute over VPN before, the route reflector receive the route, distribute over the VPN before to the other P, P2 receive that and redistribute to C2 finally. And that's how they have a ping between them. Okay, so this network is already set up with MPLS LDP. As I said, it's enabling all the network. Now we will first verify that the ping works between C1 and C2 over MPLS LDP, and I will show you what commands we need for implementing segment routing in the network, okay? So I have already the consoles open it up here. Let me go over C1. So this is C1. If you see and I type show route, we see that we have the 200, 200, 200. That is the loopback 0 of the other C2. If I pin this to this loopback using my local loopback 100, 100, 100, and I repeat 100 times, then the ping works. Okay, so it means that the traffic over the provider works as well. Now, if we go over P1, if we type here and we type show MPLS interface, we see that we have MPLS LDP enabled over the physical interface 0000 and 0001. These are these two interfaces over here, and there is an MPLS session, okay, over there. So we have two sessions, one to the router down and the other to the upper router, okay? Now, if we do show Ceph, for example, to the loopback of P2, I forgot to mention that P1 has the loopback 1, 1, 1, 1, and P2, 2, 2, 2, 2. Okay, so we know that in all labeling environment, including LDP and segment routing, the loopback are the most important because we need to have an end-to-end LSP between the PEs. If we do show Ceph to the loopback 0 of the P2, we see that the label is 24,002. And this is assigned by MPLS LDP, but our infrastructure, right? In the previous video, in the theory, we saw that LDP utilized 24,000 plus range in the Cisco software, right? So basically, in this case, we are using 24,002 to reach to P2. Okay, so this means that the labeling to P2 is okay. We can verify as well that the LSP, the traffic labeled between P1 and P2 is working with the command show MPLS IPv4. I want to reach P2 from the source 1111. I don't need to type /32, and here it works. So it means that the ping MPLS command basically is verifying that the forwarding of the traffic between P1 and P2 is labeled. Okay, this is called a feature MPLS OAM. Okay, it's a feature that you can enable over the router with this command show MPLS OAM. You can type it out there, and then the feature will allow you to perform this command. It has to be enabled in all the devices in the network if you want to test it out. This is the same command that we will use for testing out the forwarding plane segment routing, but in segment routing there is another keyword, not MPLS, but SRMPLS, right? And here, if you remember, we touched in the first video as well that SRMPLS is the common name that you will find in many books about segment routing because it's part of MPLS concept, okay? Now, we don't have here segment routing enabled. If you see show segment routing, there is nothing. Show router ISIS, there is no any segment routing configuration. Show ISIS segment routing label table. Here normally we see the prefix SIT with the loopbacks interface of all the devices. We don't have it here. So now we will proceed to enable segment routing in all the devices. How we enable segment routing, the control plane. How we do it? We do with the command segment routing, sorry, not segment routing, we need to go over the address family before, segment routing MPLS. This command enables the control plane of segment routing. So it starts the router and ISIS to propagate those TLBs that says to the others, hey, I support segment routing or I speak segment routing, okay? Now, a part of this command, we need to enable the label for the prefix SIT over the loopback, right? This command is prefix SIT. Well, we go under the loopback in ISIS, address family, prefix SIT, and I will put here just index value, okay? Index value of 1, because I want that P1 will have the label 16,001. If you remember here, we have two options to configure segment routing, prefix SIT. One is by index and the other is absolute. This is a static, and index is equal to the segment routing global block plus index. So our default segment routing global block is 16,000. So if we sum up here the index, it will be 16,001, the label for the loopback of the PE1. Okay, so in our case, we will just enable prefix index 1. If I don't specify the segment routing global block in the process of ISIS, it will take the default one, okay? The default range. I can modify the range of the segment routing global block. For example, if I do router ISIS, segment routing global block, I can specify another range, 18,000 to 20. But here I don't need, if I don't specify, it goes over the default one, 16,000 to 23,999, that is for iOS XR. Okay, perfect. Then another way that I can configure a segment routing global block is in the global mode, right? Not only under ISIS. If I configure segment routing global block under ISIS, the global block will be only used for ISIS. Remember that there are other protocols as well that I can use a labeling. BGPLU, for example, it can use segment routing as a labeling protocol for assigning labels to the prefix. So if I configure this only under ISIS, it will enable to use segment routing labeling range only for ISIS. If I want to have for other protocols like BGP, I can configure segment routing global block in global mode, right? In the configuration terminal, segment routing, and here global block and the range. I will just configure for a matter of showing, but this is actually the default global block range. But this will tell the router to use that block for any other protocol, okay? So basically these are, these are the commands that we need for segment routing control plane. Okay, so I type this commit here. Okay, I will enable segment routing in the other devices. Segment routing, just for enabling the process over. Of course, I need to type here as well under ISIS segment routing MPLS commit. I'm going to P2 now. Before I was in P1, now I will go to P2 segment routing MPLS, and I will do exactly the same in PE2. Okay, segment routing router ISIS address family IPv4 segment routing MPLS interface loopback 0 address family IPv4 prefix seed index 2, and that's it. Okay, this is the configuration again. Just to recap, segment routing MPLS for the control plane, and you have to define the prefix seed. You are wondering about where are the adjacencies set. Adjacencies set are calculated automatically by using the normal range of labeling. Segment routing use, as we saw, 16 to 23,999. For adjacency set labels, the range is from 24,000 plus. Is a default or normal range for labeling. Okay, perfect. So we enable that and we type commit. Now, in order to verify that the labels, and P1 actually knows about the labels from P2, the prefix seed of P2, we could type show ISIS segment routing label table. And here you can see that now our table in P1, I am now in P1, is 16,001 for the loopback 0, our loopback 0, and 16,002 for our loopback 2, loopback 0 of P2, that is 2222. If I type show ceph to 2222 again, you see that here the label is still 24,002, right? It's not 16,002. Why is that happening? Because we enable segment routing only in the control plane. We didn't enable yet on the forward plane. We are going to that, okay? But I just wanted to show you how to enable in the control plane only segment routing. Now, for enable segment routing and tell the router to use segment routing for the forwarding plane, we need to enable an additional command, which is segment routing MPLS SR prefer. By default, the router will prefer LDP if we have both configured LDP labels, but we can tell the router to use SR label in the forwarding plane. If you remember a bit of the labeling and how it works in the device, it contains the LIP, label information base, that is equal to the RIP. Sorry, the LIP is equal to the RIP in the IP word. So this is IP and this is label, and LFIP is equal to FIP in the IP. FIP is equal to ceph. Okay, so in order to tell the router to use for the LFIP segment routing, we need to use this command SR prefer. Okay, if not, again, by default we'll use LDP labels. So once we use this command, let's start with that, commit. We need to enable this in all the devices in the network. So again, we will enable into the other devices, P2, commit, then we go to P1, P1 address family, segment routing, MPLS SR prefer, and then to PE2, router ISIS, segment MPLS, no, address family PE4, segment routing, MPLS SR prefer, commit. Okay, so we enable into all the devices in the network, P1, P1, P2, P2, okay? We are not including the route reflector because the route reflector is not really in the forwarding plane. We don't need to have the route reflector in the forwarding plane. So meaning that we don't need to enable segment routing even in the route reflector, right? Because it doesn't switch label packets over the network. Now, if we do show ceph again, now you see that the label changed. Now it's 16,002, which is mean that it's using the labeling propagated by segment routing. If I do show MPLS forwarding, you see that in our LFIP, we have two types of labels. One that is for LDP, the ones that are 24,000, and the others are for segment routing, that is specifically this one here, okay? So this has a particular naming SR prefix index 2, that is reference, of course, to the loopback 0 of P2, okay? Now, if we try our magic command, SR MPLS 2222, /32 source 111, the ping works. And this means that segment routing is being used as a labeling protocol for the network. Okay. Now I will try again the ping from C1 to the loopback, 200, 200, 200, source 100, 100, 100, 100, repeat 100, and the traffic yet goes. I will try to do trace route, 200, 200, 200, 200, source 100, 100, 100, and yeah, numeric for speeding up. And you see that now the label encapsulation, the first one, the topmost label that normally is the forwarding label in the core, is 16,002. It's not 24,002, as we saw in show Ceph. Okay, so this is how segment routing works, how you can enable in the control plane, in the forwarding plane, how you can verify that actually the prefix seed are being correctly propagated into the between the devices. This is the command in P1. If we go to P2, show segment routing, show ISIS, sorry, segment routing label table, then you can see here what are the prefix seed for the different PEs in the network. Okay, there are other ways if we want to go into deep, well, not deep, but more into the updates that are being sent over ISIS. We can see a bit more information. So for example, in P1, we can type show ISIS verbose, and we can see what P1 is advertising over the ISIS network. And here we'll see that segment routing, sorry, ISIS and P1 using ISIS is advertising, of course, all the prefixes in the directly connected, the gigabit 000, the gigabit 001, that these are the two core interfaces, plus the loopback 0 of P1, and here we have the prefix seed with index 1. Okay, and there are some other attributes as well that we can talk about this in the next video to deep dive a bit more into segment routing. Okay, and basically this tells us that loopback 1 is being forwarded with segment routing index value with a prefix seed, and that's why we see in our table here the prefix seed of P2 and the P1 as well. Okay, I hope that this video has been informative for you and the lab was a bit interactive, and we could verify together how to enable segment routing, how to make it work in the control plane and the forwarding plane, and test it out that the traffic between the C1 and C2 work it out perfectly. Okay, so stay tuned. See you in the next video. Bye.